Hi, in this video we're going to be learning about manometer. And manometers are used to measure pressure. Of gases. And there's two main types. First we have closed. And now a closed manometer looks like this. And top here is closed. This is a gas, and then it's gonna have a liquid in here. And then it's gonna have a substance here that tells you the pressure. Alright, so in our first example, we have over here we have the distance from here to here is 740 mm of mercury, Hg. And then so our job is to find the pressure of the gas. And what we have to do when you're dealing with a closed manometer, the height that it gives you is the height of the pressure. So now the question is, given the pressure, on the gas shown here in kilopascals, kPa. And so we're gonna have to do some conversion. We have 740 mmHg, and then we're gonna have to convert into every 760 mmHg, which is standard pressure. There is 101.325 kPa. Now, if we use our calculator, we have 740 divided by 760 times 101.325. That gives us about 98.7 kPa. In closed manometer, the height difference is the pressure of the gas. And again, the height difference is the top of this bar subtracted by the top of this bar. And that's how you find the pressure of the gas in a closed manometer. Now our second type, we have an open manometer. And an open manometer looks like this. We have our gas. And then this part is opened. So air can go in from here as well. And when you're dealing with the open manometer, whichever side is higher is the one with less pressure. And after that, you add or subtract the pressures depending on what you're given. So let's come back to this example. And this time, it also looks like this. Alright, and then this height subtracted by this height, the height in between is 773 mmHg. This is a gas pressure pushing down this way. And then what's pushing down this way? The atmosphere. Which one has a higher pressure? The side with a higher pressure is going to push down harder and then make the mercury go up more on the other side. So since this side is lower than this side, we know that this has a higher pressure. And since this side is being pushed up, as you can see, is taller, this side is going to have less pressure. And again, you can look over here. Whichever side is higher is less pressure. This side is higher, so the atmosphere has less pressure than the gas inside. Now, the question is, what is the atmospheric pressure in atm if the pressure of the gas in the manometer is 1,350? So we're given that this is 1,350 mmHg. And now we're asking for what is the atmosphere pressure. Now, since the difference is 773, and the atmosphere pressure has to be less than the gas pressure, because the gas is pushing down more than the atmosphere. We're going to use a heavier one, which is 1,350, and subtract it by the difference, which is 773, to get a smaller number than 1,350, and that is 577 mmHg. And now this makes sense, right? Because gas is pushing more on the mercury than the atmosphere, which is why the mercury is taller on this side. And since the atmosphere has a less pressure than gas, you simply subtract the higher pressure one by the less pressure one. Or if you're given with atmosphere in this problem, you know that gas has to have a more pressure than the atmosphere. So you're just gonna add 577 by 773 to get 1,350 of the gas. Now, back to our problem, we have 577 mmHg of atmosphere pressure in this problem. And then we need to turn it into ATMs. Our unit has to be ATM, so we're going to use every 1 ATM, there is 760 mmHg. So we're going to divide 577 by 760, which gives us 0.759 atmospheres. And let me make it easier for you and explain it again. So in a closed manometer, height equal pressure of gas. That's it. That's all there is to it. And then you just have to convert depending on what the question is asking you. And in an open one, whichever side is higher has less pressure. And then you add or subtract this number. You add or subtract the distance, the height of the mercury to get the other one that you're looking for. Thank you for watching.